All right, here we're going to graph this rational function. It's pretty easy if you can factor. And the key points for rational function are the intercepts and the asymptotes. So I have them ready to go on the bottom of the screen. So let's do it. The first thing I'm going to do is I'm going to factor it. But before I factor it, I'm going to look for horizontal asymptotes. You always want to look for horizontal asymptotes when it's in this form. And you can see the degree of the top is 2. Degree of the bottom is 2, so they have the same degree of the top and the bottom. When the top and the bottom have the same degree, the horizontal asymptote, I'm going to do it down here, is the ratio of the leading coefficients. So the top leading coefficient is 2, the bottom leading coefficient is 1, so it would be y equals 2 over 1, or y equals 2. That's an easy one. So that's only because their degrees were the same. There's different rules if the degrees are not the same. So you should also find the y-intercepts when the function is in this form. So the y-intercepts, you just plug in 0 for x. So basically the y-intercepts you're going to be left, when it's in this form, you're going to be left with this number over this number. So because x is 0 for y-intercepts, all those disappear. So the y-intercept would be negative 16 divided by negative 4, which is 4. So the y-intercept would be located at 0, 4. So that was easy too. So the x-intercepts and the vertical asymptotes, you typically want to factor this because it makes it easier to find. So we're going to factor the top and the bottom. The top, if you notice, there's a common factor of 2. So let's get rid of that. It will simplify our factoring. The bottom is still the bottom. And then I'm going to factor the top and the bottom, or finish my factoring at least. So on the top, factors of negative 8 that add up to 2 are positive 4 and negative 2. On the bottom, the factors of negative 4 that add up to 3 are negative 4 and positive 1. So now I have it factored. X-intercepts are where y equals 0. And this is a huge fraction, and a fraction only equals 0 when the top equals 0. So therefore, the top would equal 0 when x plus 4 equals 0, or, and this is x-intercepts, or x equals negative 4. And also when x minus 2 is 0, so x equals 2. So I'm just setting the top equal to 0 for the x-intercepts. I have a negative 4 comma 0 and 2 comma 0. The vertical asymptotes happen where the fraction is undefined, and basically that happens when the bottom is 0, but the top does not equal 0. So since we have no common factors, the bottom is going to be 0. You can see at 4 and negative 1, and neither of those will make the top 0. So vertical asymptotes, we're doing the same thing as x-intercepts basically, but we're using the bottom. So for the vertical asymptotes, you're looking at the bottom. X equals 4 would make that factor 0, and x equals negative 1 would make that factor 0. So the vertical asymptotes are actually x equals 4 and x equals negative 1. Now just a comment here. Vertical asymptotes and horizontal asymptotes are equations of lines. That's why you need the x equals for vertical asymptotes. That indicates a vertical line. And you need the y equals for a horizontal asymptote. That indicates that horizontal line. And now I'm going to start plotting this to see what we can do. So, one thing I forgot to mention. The x-intercepts, look for multiplicities. The multiplicities are 1. These happen both one time. So the graph will go through. So x-intercepts are negative 4 and positive 2. The y-intercept was 4. The vertical asymptotes were -1 and 4, x equals -1. And x equals 4. And finally, the horizontal asymptote was y equals 2. So now we're ready to at least start graphing this. Actually, we can graph the whole thing, it looks like. If you have to really think this out. So I'm going to start on the left. I'm going to go, and then I'm going to go to the right. I'll worry about the middle later because I want to use these horizontal asymptotes. The horizontal asymptote, the graph must approach it on the left and the right. So I'm writing that right now. So now, at each vertical asymptote, the graph has to shoot straight up or straight down. We know that. So the first third of the graph, which is from here to here, from asymptote to asymptote, it has to go through that x-intercept because it had a multiplicity of 1. So it should just keep going straight down to that vertical asymptote. It couldn't jump back up if it goes through because you would be creating another x-intercept that we don't have. So that's the 1/3 of the graph. I'm going to do the same thing backwards over here on the right-hand side. I'm going to start at my horizontal asymptote, and I could do what I did on the left, go down like this, except I don't have an x-intercept over here. So that forces me to go up. So now I'm done with 2/3 of the graph. The only thing I have to worry about is this middle part. So I only have 2 points, and I could go up or down by these asymptotes, so it seems like there's not enough information sometimes. But in the middle, between these asymptotes, the graph has to pass through these points and the intercepts. And this x-intercept has a multiplicity of 1, so it must go through. Therefore, the graph is going to go through it, and it can't come back up because there's no other x-intercept. So this vertical asymptote must keep going down. So the vertical asymptotes always must go straight up or straight down. And on this side, you can just see it has to keep going straight up. It couldn't turn around and go down because then it would have to go through the x-intercept, and we don't have an x-intercept there. So it's pretty easy. We didn't need any extra points. All we needed was the intercepts and the asymptotes, which was nice. So that's a good representation of this graph. And then you should take your graphing calculator and see if it actually looks like that. And I promise you that it will. So hopefully that helps. I'll see you in the next video.